Here we have another cool Asus laptop that came in for repair. This one is the Vivobook S15, and it looks something like this. Orange bezel, and if we open it, the laptop looks something like this. Laptop came in for no power. One thing I noticed, when the battery is plugged in, let's plug power, and I just want to show you what's going on. When the battery is plugged in, and that is the reason why I have the battery plugged into the motherboard, we do not see any blinking light. Actually, we do see a white LED and an orange LED. It came in for a split second and back out. We no longer see a white or orange LED. Just came in for a split second. Now, what happens when we unplug the battery? Battery out. Two orange blinks. One blink and not two blinks. Now we have two blinks. We have nothing for like 10 seconds. Strange. I mean, there's no pattern on how that light blinks. We cannot go online and search for 5 blinks, 6 blinks, blinks every second, blinks every 2 seconds, because the blinking looks intermittent. We're going to have to take a look at the board and see what's going on and why that laptop is not powering on, because the battery is not powering on the laptop and the charging cable is not powering on the laptop. So we know that we have a problem with the motherboard. We can start at the charging connector. The first thing I want to do is measure for a short, but I highly doubt that we have a short on the power MOSFETs. Let's measure here. I'm reading 0.461. That's awesome. 0.4 is a good reading. If we test the gate on this MOSFET, we do not get a reading, and here we get a high reading of 2.3 voltage drop. So we know that we do not have a short circuit on the main voltage rail. We're going to do a quick visual inspection because right now I do not know where to look. So the first thing I want to do is do a quick visual inspection just to see if there's anything discolored, anything blown, any signs of liquid damage, whatever the case may be. And it only takes 2 minutes to do a quick visual inspection. I'm a lot faster than this, but because I'm doing the video for you, I'm taking it easy. I visually inspect motherboards like Superman. 1.5 seconds. We see a lot of MOSFETs in this area. Looks like the V-core MOSFETs. That's our CPU right here. And we have, you know what, why not measure MOSFETs while doing visual inspection so we can hit 2 birds with 1 stone. What the? Look at this. Source is shorting out with gate. If we go to ohms mode, what reading do we get? 0.5 ohm reading. That's bad. We're going to have to put a question mark on this one. If we measure in ohms mode, we have 5 ohm reading here, and that's extremely low, because if we measure this one, we have 285 kilo ohms. We are reading 5 ohms here. That's almost a short. And gate is shorting with source. So that's a no-no. Because if we measure from here to here, we should have a very high number, 285 kilo ohms. But from here to here, we have 1 ohm. A question mark, let's put a question mark on this one. You like that question mark? Measure this one. Let's go back to diode mode. If we measure the gate on this one, normal 0.4 or 0.43. And if we measure between this and this, also 0.43, no short. If we measure here, we do not care about source, but we care about gate here. We have a short also. And if we measure from here to here, we have a short. So wait a minute. So we have a short here. We have a short here. Is that normal? Oh, look at this. We do not have a short now. Now we are reading 0.6. So what happened before? And if we measure between this and this, we also do not have a short here. 0.6 voltage drop. But we have a short here. So the question mark component will have to be removed, and then we're going to check again. But let's continue with visual inspection. We did not remove the board out of the laptop because most of the components that we need are on this side of the board. What is that? I see signs of something here. No work was done in this area. All solder joints are factory, but we do see signs of, is that liquid? Or could that be from the heatsink that was on? No corrosion and nothing major. So I do not see anything else wrong with the board based on quick visual inspection, but we do see a problem here. The nice question mark marking. Question mark marking. Let's remove that component. And this one is, which one? Let's mark it with the Sharpie. And that's a trick I use to read chips. You see? Look at how visible the number on the chip is. 4C09B. So you can use a Sharpie just right over the chip, and you will be able to see the readings on that chip. Now you're going to see everybody using a Sharpie to read numbers of the chip. But that's why I show the tricks on this channel, right? We're going to remove the chip, and we're going to measure for a short again at the gate and see what happens. Let's measure in diode mode, and hopefully the short is gone. Wow. 0.49 voltage drop. The board is still hot, so the reading will be a little bit over 0.4, 0.53. Anywhere from 0.2 to 0.8 I'm okay with, and we are reading 0.5. Awesome. We need to grab a similar component. Where do we grab one from? Okay. Is that 6 or 9? 6. We need the 9. What about this one? Is this one the 6 or the 9? That's the question. Right there. Got it. We got it. But we have an aluminum capacitor here. We have to be careful. If we apply too much heat on this cap, it's gonna pop. And we have a battery connector here. I do not want to burn it because we can use it for another customer. You know what? Let me pick another board. If we check this donor board, I just want to see if this one is the 6 or the 9 or even the 5. This one is the 9. Perfect. Asus like to mix things up, so every board has a different MOSFET. If solid had lattice only, it would not be fun, right? Mix it up. One time add the 9 MOSFET, one time add the 6, one time add the 5, one time add the MOSFET that we cannot even figure out, and that's the way to go. I would say Asus is a lot better as far as repairability goes compared to other brands. Now what I want to do is apply just a tiny bit of flux and solder. We're gonna go like that, and let's solder that MOSFET on the board. Wow, 0.5 voltage drop. Look at this. We did it. All we have to do is plug the charging cable and test. That's all we have to do. Which way is it? Plug it here. And are we gonna see something good? I do see the white light and orange light, but we want to see the laptop turn on. I do not have the fans or heatsink connected, but I'm very optimistic we're gonna have something positive. Or maybe not. Both the white light and orange light are blinking. You know what, let me connect the battery and try again. Now, two options. Either the V-core MOSFET will fix the problem, or it could be that the V-core MOSFET allowed more voltage to the CPU than what the CPU can handle, and we have that CPU. One of the two. That's always the case. Now with the battery connected, I'm not seeing any lights. So we probably have a faulty battery. Let me disconnect the battery. And are we gonna get a light? Yes, we got the light after disconnecting the battery. So the battery may be faulty. Let me grab the thermal camera quick and maybe grab a fan just to see if the fan is spinning. Okay, so the fan went in. Right here. And let's try to power the laptop on one more time. I just want to see if the fan will spin. We got rid of the short by replacing the MOSFET. Plug the power cable. And we do see a white and orange LEDs here. Oh, and the fan is spinning. Look at this. And the fan stopped. The fan went on for a few seconds and then back off. And it's still off. Plus, I do not see any lights anymore. I do not see a white light or amber light down on the bottom. So the lights did come on, but now everything is off. What happens if we press the power button? Okay, so the fan did go on when I pressed the power button, and it went back off again. That's a very good indication that we may have a faulty CPU. But let me go over the MOSFET again. Meter in diode mode. And we're gonna check the MOSFET that we replaced that was initially shorting out. Meter in diode mode. And you see, we do not have a short anymore. That's why the fan came on. Before, we did not get any fan spin, but now we do have a fan spin, and the MOSFET is good. Measure the other ones. Look at this. Now this one is short into ground. Before it was this one, now it's this one. And this one too. What the? We fixed one, and two more went bad. So I took one out. But let me measure this one again after taking the other one out. Now look at this. We don't have a short anymore. We do not have a short anymore. So is it possible that this one was causing this to short out? This guy here? Strange. Very strange. What's happening here is not normal. Let's grab a replacement MOSFET from this board. We already borrowed one from here, and we're gonna borrow this one now. And let's see, do we still have a short? And we do not. We do not. And we do not. Let's try the laptop now. The fan is spinning. The fan is still spinning, and it went off. So we got nowhere. The fan went on again and off. And the fan is not spinning anymore, and we have the same light pattern. The light is completely off, but it's gonna come back on. Strange random pattern. Let's wait some more. One orange light after a long wait. Another long wait. See? Blinked twice and went off. Strange. The blink pattern is not consistent. One last thing I want to do is just go over the MOSFET again before we end the video. Some viewers may ask, why not replace the CPU? Reason number one is you cannot even buy those CPUs, and if you can buy it, you're going to buy it from somewhere, from China, and you do not know if that CPU is working or not. You reball it, you spend the time to install it, to solder it, and then you realize that did not solve the problem. But maybe the CPU was bad to begin with, the one that you bought. That's number one. And number two, CPUs are not cheap to buy. And they're not cheap to reball and solder back on the board. So it's neither practical nor economical. That is the reason when we have a problem with the CPU on any laptop, we deem it a no fix. Measure here again. We do not have a short. Measure here again. And we have a short again on this one. and we have a short on this one also. What if we remove this one? Are we gonna get a short on the other one? Let's check to see if we have a short here. And we do not have a short anymore. What about here? We do not have a short anymore, and we have a 0.5 voltage drop. And what about here? We do not have a short anymore. What if we try the laptop like this? Because here we're playing Tom and Jerry, cat and mouse, catch me if you can. Now I noticed one change. The orange light is blinking along with the white light. Look at this, that was not happening before. The orange light is coming on and the white LED is coming on, both of them. Before that was not the case. So by removing, let me put the microscope, look at this. Orange light is constantly coming on and off, and then the white light and the orange light and the white light. That was not happening before. But of course we're not going to be able to turn the laptop on in this condition, and if we do attempt to turn it on, nothing happens. The fan does not even spin. Let's go ahead and measure everything again after we attempted to power the laptop on. We have a short here, you see? We have a short here even after removing this MOSFET and the bottom one. So right now what we can do is we can inject voltage at the short right here and see what happens. And we have a short on the bottom also. We're gonna set our voltage injection tool to about 1.4 volts. Amps, it doesn't matter, we have it set at 5 amps. This voltage injection tool you can purchase directly off our site if you have not already done so, along with everything that we use on our bench here, including hot air station, soldering station, tweezers, flux, braid wig, multimeter, probes, everything. We have all items in stock, and all orders almost always ship out same day. If we inject voltage here, we have an amp draw of 0.2, which is very minimal. What about here? So it means we do not have it that short. Let me go to ohms mode and measure again. Ohms mode is reading 5 ohms. And we are reading 5 ohms here also. 5 ohms on a gate is extremely low, very, very low. We're gonna test in diode mode. So to summarize, we had a short here only. We replaced the MOSFET and the short is gone. So if we measure here again, we do not have a short. If we measure the neighboring component, we do not have a short. But then after turning the laptop on, now we have a short on this one and we have a short on this one. So I removed this MOSFET and the short was gone from here. I powered the laptop on and same issue. But now we have a short on both. I removed both MOSFETs and we still have a short on both of them. What does that tell me? It tells me nothing. I'm running out of ideas. I don't know what to do next. The only thing I can think of is a faulty CPU. Let me know what you think. Leave it down in the comments and maybe we'll do a part 2 on this one. I hope you enjoyed the video even though it was a no fix. Don't forget to like and subscribe and we'll do something else in the next video. Strange. Let's take a look at the board. That's most definitely a hardware issue because the laptop is not powering on, not on battery and not on battery power. Let's plug power one more time and just look at this area. لا حول ولا قوة إلا بالله.